In this section, we'll discuss about synthesis of amines and some of the reactions given by amines. The first reaction that you're looking at involves ammonia and methyl bromide. So methyl bromide represents one alkyl halide, and I mentioned before that Br is a very good leaving group, so that favors this kind of reaction. So electron pair on nitrogen gets attracted to carbon because that's delta plus. But keep in mind that here the bonding in methyl bromide is between carbon and Br. So the bonding is like this, CBr, without the hydrogen. So electron pair, when it goes to carbon and then Br gets out, because carbon must preserve its 4 bonds. So you end up with methylamine, which is a 1-degree amine. Remember 1-degree amine? When nitrogen is bonded to only one carbon, so that's why it's 1-degree amine. In 2-degree, nitrogen will be bonded to 2 carbons. In other words, 2 groups that would have carbon directly bonded to nitrogen. Now, let's look at the formation of 2-degree amine from 1 degree. So we start with methylamine, which is 1-degree amine. Again, we're allowing it to react with methyl bromide, another mole of methyl bromide. So again, the nitrogen is attracted to CH3 because that carbon is delta plus and Br is delta minus. So electron pair would go here, then carbon has to give up its electron pair to Br. So Br is going to go away as Br minus. And you end up with this structure. Because there are 2 methyl groups, because you already had one of them in 1 degree. So because of the second methyl group coming from methyl bromide, you end up with a 2-degree amine. Now you can see here the bonding, sometimes in this kind of a structure, is not very explicitly shown which atom is bonded to which atom, especially the left-hand side methyl group. I'll show you this so that in the future you can just understand it. Nitrogen with electron pair, methyl group with carbon and 3 hydrogens bonded to carbon, this hydrogen, and you have carbon and 3 hydrogens bonded to this. So I'm going to write down like this. This way you see that nitrogen has 2 carbons bonded. Each carbon is coming from a methyl group. And that's why it's a 2-degree amine. Again, starting with the 2-degree amine, dimethylamine, and if you allow it to react with another mole of methyl bromide, again the 3rd methyl group gets bonded and you end up with a 3-degree amine. Again, this time nitrogen has 3 bonds with 3 different carbon. Each such carbon is coming from methyl group. If you follow the series of reactions between ammonia and methyl bromide, you see that there are several different types of amines are formed. Like you have 1 degree, 2 degree, 3 degree, and now you can get quaternary ammonium salt. So basically all those compounds you can get depending upon how many times it got chance to react with methyl bromide. The first reaction, ethyl chloride with sodium cyanide or sodium nitrile, gives you ethyl cyanide or ethyl nitrile, C triple bond N. Now keep this in mind that once you got cyanide or nitrile, which is C triple bond N, and obviously you have C other 2, lithium aluminum hydride is going to form H minus, and H minus will be attracted to this carbon, and eventually some of these bonds will break down and you get CH3, CH2, CH2, NH2. This is 1 degree amine you can get. So from nitrile, after reaction, you get 1 degree amine. Now from halide, like this, CH3COOH, starting with carboxylic acid, you let it react with thionyl chloride, SOCl2, that changes OH. Let me highlight that in blue. That changes OH to Cl. So once you get the chloride, then you change it to amine by letting it react with ammonia. So you let it react with ammonia, and ammonia is going to replace, so ammonia pair of electron on nitrogen is going to go over there, Cl would get out, and then you finally have this compound. This is amide, C double bond O NH2. So when you let it react with lithium aluminum hydride, that's what you're showing you here. So when it allow it to react with, let's try another pen, not to get confused. So once you have this amide C double bond O NH2 and let it react with lithium aluminum hydride, it changes into CH3CH2 NH2. So it's just a 1 degree amine. Now we'd like to discuss about two problems, which is part of problem number 7, chapter 12, and page 411. The question is, propose structures for amides that might be precursors of the following amines. So basically they gave you amine structure, and you need to find out what amide structure is going to give you this product. So let me write down the part B. The actual question is, and I'm going to write down a little differently so that you can see actual structure, NH, and there are two groups, which is CH2, CH3, and that's another one is also bonded like that, CH2, CH3. Question is, how do you get this compound starting from an amide? So basically you're going to use lithium aluminum hydride for reduction, and you must have C double bond O somewhere here. Now in this reaction the number of carbon remains unchanged. So basically adjacent to nitrogen, the carbon adjacent to nitrogen, you just replace one of these with C double bond O. So basically this is what you're going to have. If I work on this carbon, it doesn't matter, both are similar. So H, and now I'm introducing C double bond O. So C double bond O because that's the amide. Now carbon can have only 4 bonds, so the next bond would go to CH2 and CH3. CH2, CH3. And the other bonding remains the same, CH2, CH2, CH3. Now you can always double check. Lithium aluminum hydride is going to offer H minus, and that H minus would be attracted to this carbon. So initially it becomes CHOH and then becomes CH2, and then OH would go away. So if you end up with this compound. So we are right in predicting the amide. So this amide would have this structure. So NCO CH2 CH3, and on the other side it would be CH2 CH2 CH3, and N would have 1 hydrogen bonded. Now let's go over part C. Again, amine structure is given. You need to find out what amide structure would give you this particular amine structure. So it'd be, say, CH2 NH2. Okay, what basically I'm going to do is, to make it amide, the functional group of amide. Let me remind you that in case you forgot. C double bond N, that's the amide functional group. So I'm going to introduce it here. So let's do that. Instead of CH2, I'm going to write down C double bond O NH2. Now I'll have to use lithium aluminum hydride. It's a well-known reaction. So lithium aluminum hydride is going to change amide into amine. And keep that in mind. First you add lithium aluminum hydride. In next step you add water in both cases, water or H3O plus, because that would give you finally this compound. Now here we're showing you more reactions that may result in amine, like paranitrotoluene. This nitro group, in presence of hydrogen and platinum. Platinum is the catalyst. It helps in this reaction. NO2 group is changed into NH2. So it becomes paramethyl aniline or aniline. Or alternatively, you can also apply this. Iron and H3O plus, that gives you NH2, and then of course followed by, you need to have sodium hydroxide so that it's not NH3 plus. Sodium hydroxide is going to neutralize that acid. So you end up with paramethyl aniline. So basically reduction of nitro gives you an amine group. Now there are some reactions that we would like to go over. Here you have an amine where R could be alkyl group or some other groups, and pair of electron from here goes to positive carbon, because oxygen is more electronegative than carbon, so make carbon more positive, and so that attraction happens to that carbon, and eventually this kind of bonding would lead to this product. Now, so you can see that the mechanisms are very similar. So nitrogen with pair of electron goes to the carbon, which is positively charged or slightly positive charged, and that would lead to the final product formation. Next, we are going to discuss about heterocyclic amines. In this particular case, you can see the ring structure has nitrogen instead of carbon, so it's not all carbon. In benzene ring, you have all carbon. So in this case, there are 4 carbon, 1, 2, 3, 4, and fifth one is nitrogen. That makes it heterocyclic amine. And this is also amine because of NH bond. In presence of nitric acid and acetic anhydride, it gives you a nitro group. So this is 2-nitropyro as the major product. Now there are several other heterocyclic compounds. Pyridine is one of them. It's a very well-known organic compound. Then quinoline, isoquinoline, these are anti-malarial drugs. And then indole is the next one. You don't need to really memorize most of these compounds. Of course, the pyridine is so common, make sure you know that. Pyro. I mean, I just remember by thinking about pi, and if I draw it like this, that's shaped like pi. So that's my way of remembering the name of this compound. But keep in mind it's heterocyclic with nitrogen as part of it, and the top part of it looks like pi. So that's how I remember it to be pyrrole. In this slide, you are looking at pyrrole, the first one. The next one is very similar to pyrrole, except that ring has another nitrogen. So there are two nitrogen in the ring structure, and it's called imidazole. Then pyrimidine has two nitrogen in ring structure.